So, the first law of thermodynamics. There are actually 4 laws, 0 through 3. The first 3 laws had already been discovered when somebody said, look, we actually do need, for very good reasons, to have this other law, and it's the most important one, so we need to put it as the 0th law. So, those are their various laws. So here's the first law. Remember, laws are patterns in the behaviors of things. So observations of chemical reactions and energy changes and so on led to the formulation of the laws of thermodynamics. They're all important for thermochemistry, and they can all be stated in multiple different ways, some of them through words and sometimes with math. So thermochemistry means we're studying heat, the transfer of thermal energy, so that we can understand when and why chemical reactions take place. Okay? So as for laws,
The law! I never broke the law! I am the law! You betray the law! Law! Mr. I am the law.
okay, that was Judge Dredd. He is the law. All right. So the first law of thermodynamics is energy is neither created nor destroyed. It only changes form. Okay. Or, to put it another way, the internal energy of an isolated system is constant. Okay. Internal energy means all of the energy inside of something, and an isolated system is one where neither matter nor energy can get in or out. Okay? So the universe is an isolated system. Okay? There's no way in or out of the universe. So that means that the total amount of energy in the universe is constant. Or, in certain situations, depending on how things are set up, the change in energy for a system will be 0. Okay? If the energy is constant, then that means there can be no change. Okay? So a lot of times we spend a lot of effort constraining systems, putting limits on them, putting boundaries on them, so that we can force energy to move or not move in certain ways so that we can measure it. And a lot of times, being able to isolate your system so that no energy can go in or out is the easiest way to do that. So that's the first law of thermodynamics. The energy is conserved. It's one of the laws of conservation. So energy neither created nor destroyed. And so in some situations, the change in energy for a system will be 0. Okay. That is not always the case. Okay, the first law of thermodynamics only applies to an isolated system. Okay, so let's bring this back up. This may show up in a later set of slides, but I want to cover it now. A system can be open, closed, or isolated. Okay, an open system is matter plus energy free in and out. So an open system, matter and energy are free to move in and out of the system. For a closed system, matter no, energy yes. Okay. A closed system is matter cannot go in or out. Okay, but energy can. And finally, isolated, matter no, energy no. So that means that no matter can go in or out and energy cannot go in or out. So we can do open systems and closed systems very, very easily. You know, an open system, is just a cup. A closed system, a sealed bottle does pretty well at being a closed system. An isolated system, technically only the universe can actually be an isolated system. But we can do a pretty good job of getting close to an isolated system. If we take, say, a closed system and then just insulate the hell out of it. Okay, so we really, really seal it off, right? Then that can approximate an isolated system. Now, all three of these are valuable for doing theoretical work and coming up with different ways of discussing systems and energy and what it means for matter and so on. An isolated system really makes things easy because then the energy inside the system will be constant. For a closed system, the energy inside the system is no longer constant, and therefore it makes a lot of the math a lot harder. All right, so that was the first law of thermodynamics. There's not a heck of a lot to it. This delta E equals 0 thing, that, like I said, is really important. That only shows up for an isolated system, but it really does let us do some really powerful stuff, some important work. Okay, so that's it for the first law of thermodynamics. In a couple minutes, we will talk about state functions versus path functions. See you soon.